All right, today's lesson, that's 310, 22. So our object today is factoring trinomials with a leading coefficient. What the heck? Don't you wish I'd just use real words? Coefficient. Don't you wish I'd use real words instead of these math words? Well, we know a lot of what these words were. We know what factoring means, right? We're going to go parentheses, 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 right? And then trinomial, you got 1, 2, 3 terms, right? So it's a trinomial. But the leading coefficient is the number in the front. That's a leading coefficient. So the standard form, if you have y equals some ax squared plus bx plus c, this number is a leading coefficient. Before we didn't have one, which was really slick. It was nice. I liked, and you don't have to write this example down. You know how to do this, x squared plus 7x plus 12. These are great. These are fun because it works. This times this, and they have to add up to this, right? 3 and 4, right? Easy. Doesn't work that way. Doggone it. So once you get a number here, it gets harder. I don't mind harder. I'm smart enough I can do this. So, if I look at the multiples of 5, they won't make an 11. There's no way. 5 times 1. 5 times 1 is 5, but 5 plus 1 does not make 11. Everybody agree with that? So, we're going to have to start at least here. At least start there, because we know we're factoring. We're going to undo a FOIL problem, right? So at least start there. Parentheses, 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 okay? So we're undoing a FOIL problem. And then the next thing we would do is start with the leading coefficient, okay? There's only one way to make it 2x squared. Only one way. You guys agree? 2x times x. 2x times x. The only way. So I'm going to go 2x and x there. How am I doing? Now, there's only one way to make a 5, and that's 1 times 5, but I have to be careful where I put it. I'm going to put it in the wrong spot first, and then we're going to talk about why it's wrong, okay? So if I put the 5 here in my pencil, 5 and 1 here, that won't work. Can you see why my problem's wrong? So you check it with a double smiley. So if I check it with my double smiley, it's the outside and the inside that have to make the 11. So that's a 2 and that's a 5. A 2x and a 5x will not make an 11, right? So, doggone it. Yeah, so Grace, you're totally right. You get this, don't you, Grace? If you switch it, and some kids can see it right off the bat, and they don't have to try it because they can see it. If I put the 1 here and the 5 here, because maybe you saw the 10 and the 1. Anybody see it right off the bat? Good. So there's a 10. You see the 10x and the 1x. So you have to check it. So if I go, I can get a positive 10x, a positive 1x. They add up to 11x, and that has to be the answer. So what we have to do is we have to check it. We have to check the middle term. So I'm going to make a little note here. We're going to check the middle term that's that one right there, or in this case that one right there. Check the middle term with the, and I like to call it the double smiley. If you know Landon, some of you know Landon, right? Landon would always call it the double frowny because it was math. Even my kid didn't like math. He's taking a math class in college now. Love it. Okay, so check the middle term with double smiley. Landon always called it the upside down frowny. Okay, now number 2. Well, let's start with parentheses, parentheses, okay? Okay, start there. That makes sense. And 3x squared. How are we going to make a 3x squared? There's only one way to make a 3x squared. You guys agree with that? 3x and x. Thumbs up so far? Now, let's be smart. Let's be smart, okay? There's only one way to make a 1. 1 times 1. You guys agree with that? except for it's going to be negative, negative. How do I know it's going to be negative, negative? How do I know it's got to be negative, negative?
Equal to positive?
Yeah, negative times negative makes positive, but I've got to get a negative 4x. That makes sense why I'm going to go negative, negative? So if I went 1 and 1 like this, and I put my 1 down, I check my double smiley, check my double smiley, I'm going to get a 3x and a 1x. That does make a 4x, but not a negative 4x unless I make it a negative 1 and a negative 1. Okay, and I can check my double smiley, check the middle term. I'm going to get for sure a negative 1x and a negative 3x, which does make my middle term. Okay? All right, let's do example 3. All right? Do you want to try it? Why don't you try it? Try number 3. You're going to need a positive and negative. I will give you that hint. You're going to need a positive and negative because of the negative 3, right? So give it a try, and if you get it, awesome, okay? You'll know with the double smiley if it works, right? And if you have no clue how to do it at all, just wait, and I'll do it with you, okay? We'll do 2 days of this. You can imagine why we're going to do 2 days of this, right? So, 2x and x. Thumbs up, everybody should agree with that, right? Now, 3 and 1. Where'd you guys put it? 3 and 1. Did you go 1 here and 3 here, or did you go 3 here and 1 here? What'd you do? Did you go 1 and 3 or 3 and 1?
3 and 1.
You went 3 and 1. Okay, Scott says 3 and 1. I think you're right, Scott, because I got a 3x and a 2x, right? But I need a negative 1. So how am I going to make a negative? Because I get a 3x here and a 2x here. How am I going to get a negative 1? I agree. 3 and 1 is totally right because if I...
You do minus 3 and
Yes, yes, yes. Has to be minus 3 and a positive 1. Now, why did Scott say that? This now is a negative 3x, and this is now a positive 2x, which add together to make the negative 1. Nice job, Scott. This is hard, isn't it? Makes you think. You're going to have to rearrange things to try. Okay, now, example 4. Example 4. Well... the hard part about example 4 is think about this. 16, 1 and 16, 2 and 8, 4 and 4. Ooh, we got a lot of combinations, don't we, okay? I do know I'm going to go 3x and x, right? I know I'm going to do a positive times a negative. I know I'm going to do that because I've got a negative 16, right? What do you think? Anybody want to take a stab at it? Any guesses? Guesses are okay. Because we can just try the guess, and if it doesn't work, we'll try something else. Anybody have any guesses?
8 and 2.
8 and 2. Okay, so here's my 8 and my 6. 8x, 6x. It doesn't make 22, but, okay, that's all right. Good guess, Calvin. Thank you. So, 8 and 2 didn't work, but maybe 2 and 8. What do you think about 2 and 8? Let's try it. So I'll go 2 and 8. Got to use my eraser, see if this works. So let's go 2 and 8. Oh, I think that might work. Calvin, you came up with a good combination, but we just had them in the wrong spot. Now, why do I think this might be right? Well, 2x and 24x could make it 22, right?
But you have to do minus 2.
Yes, yes, yes. So you got to do a minus 2 and a positive 8 because that makes the negative 2x positive 24. Nice job, Scott. You're getting this, aren't you? I know. It's not. This is not easy. This is like, it's almost like doing a puzzle. I don't know if you guys like puzzles or not, but this is like doing puzzles, isn't it? Kind of like Sudoku or whatever, right? Okay, all right. Ready to turn the page? Nice job, Calvin and Scott, okay? Now, number 5. Here comes a hard one, okay? So we'll go frowny face. Ugh, hard. You know why this one's hard? There's 2 ways to make a 6.
Oh, no.
There's 3 and 2, and there's 6 and 1. So what do you want to start with? Oh, wait, there might be something to make it easier. I might have a way to make this easier. So before I do that, do you see anything? I sure do. So before we factor this, do you see anything? Yes, Tava.
They're all divisible by 6.
So let's factor out a 6, and that might make it easier, right? I mean, because if I can make it easier, let's make it easier. So I agree with Tava. So we'll factor out a 6. I have an x squared minus a 2x minus 3. Oh, now it's easy because it's like what we did yesterday. Right? Nice job, Tava, for making this easy for me. So then, x and x, right? What are the multiples of 3?
1 and 3.
And I think if I had a negative 3 and a positive 1, and the double smiley still works, doesn't it? There it is. Negative 3x, positive 1x makes my negative 2. Whew, thank you, Tava. This almost was a hard problem. Almost. But it wasn't, was it? So I need, for the answer, I need everything. I need the 6 there also. Does that make sense? The 6 has to be there because the 6 is actually part of the problem. Okay, now how about example 6? Now equals 0, which means I'm going to have to solve, which means I'll need to factor. I'll need many equations to get my answers, okay? All right, so let's factor. All right, let's factor. Anybody see something? Anybody see something? Yeah, divide by 5, divide by 5, divide by 5. So let's factor out a 5, okay? If I factor out the 5, it's going to make the problem easier. So x squared minus 3x minus 10, okay? And then I'll have the 5. Now this is getting easy, huh? X times x, correct? And we'll do a 5 and a 2. We'll go negative 5, positive 2. You guys agree with negative 5, positive 2? Now, because we have an equal sign, we're not done. We have an equal sign, we're not done. We've got to do our mini equations. We've got to do our mini equations because of the equal sign. So I'm going to go, well, hold on. What's this 5? What the heck? Does this 5 have an x? Think about this. How many answers? 2 answers. You guys agree? It has to be 2 answers. 2. Why do I say there's 2 answers? Why do I say there's 2 answers? X squared. X squared. So the 5 isn't an x, right? So the 5 is not going to be part of my answers because I could really just divide by 5, divide by 5. The 5 is gone. So I'd really have an x minus 5 equals 0. And x plus 2 equals 0, right? I'd solve plus 5. One answer is a positive 5. Minus 2, the other answer is a negative 2. Okay? Now, let me stop recording, and then we'll take a little mass... Huh?
You could just erase the 5.
Yeah. Yep. If it had an x, you couldn't. But it doesn't, does it?
Yeah.
So we just got rid. Only because of the 0. Only because it equals 0, right?